Welcome back to today's Explainer, where we're diving straight into Section 24.3 of our software engineering textbook, focusing on reviews and inspections. If you're studying to become a software engineer, this is an absolutely crucial cornerstone topic. We often think of software engineering as just typing out code, right? But ensuring that code is actually of high quality is just as important. So today, we're going to look at the formal techniques that professional teams use to guarantee their software is reliable, maintainable, and completely free of defects. Here is our roadmap for today's lecture. 1. Introduction to quality reviews. 2. Purpose versus progress reviews. 3. The 3 review phases. 4. Deep dive into program inspections. 5. Using inspection checklists. And finally, 6. Summary and next steps. Section 1. Introduction to quality reviews. Unpacking the static approach to finding bugs. Okay, I want to start off by asking you a question. Is testing the only way to find bugs? If you're learning to program for the very first time, you might naturally think that executing tests is literally the only way to evaluate your coding skills and find errors. You know the drill. You write the code, compile it, run it, and wait to see if it crashes. But actually, that's simply not true. In a professional environment, relying only on testing is surprisingly inefficient. And that brings us to a really vital definition. Reviews and inspections are quality assurance activities that check software, documentation, and process records for errors, omissions, and standards violations, all without actually executing the program. Think of it like a highly structured, peer-driven process. A team sits down and reads through the code or the system documentation line by line. They aren't running the program at all, they're critically analyzing the text itself. And it turns out this is incredibly effective. We refer to this approach as static verification and validation. That word static is the key here. Unlike standard testing, which is dynamic because the program is actually running in real time, this is a static alternative. So why does that matter? Well, during normal dynamic testing, one error can often mask or hide other errors. Like if the program crashes at line 10, you're never even going to see the bug waiting for you at line 50. But with static verification, errors don't hide behind other errors. You can systematically find multiple faults in a single session. Section 2. Purpose versus progress reviews. The ground rules and culture. Before we look at the technical workflow, we absolutely have to address the human element, because the culture here is everything. The crucial point is that quality reviews are a public process of error detection designed to improve the program, not to evaluate the programmer. Imagine sitting in a room while your colleagues just point out flaws in your work. It can feel super intimidating, right? That's exactly why managers must foster a blame-free culture. The goal is to make the software better, not to point fingers. This is entirely different from a management progress review. Progress reviews are purely administrative. They focus on checking schedules, monitoring budgets, and asking, hey, are we going to hit our deadline? Quality reviews, on the other hand, only care about the integrity of the code. Section 3. The 3 review phases. Breaking down Figure 24.7. Every single successful review follows a very specific, structured workflow. Phase 1 is pre-review activities. Phase 2 is the actual review meeting, and Phase 3 covers the post-review activities. Let's break down exactly what happens in each step. In the first phase, pre-review activities, we handle the logistics. We plan the meeting, set a time, and distribute the documents or code. But most importantly, each reviewer independently reads the code beforehand to spot errors and departures from standards. You don't just rock up to the meeting blind. You come prepared, having already done your independent analysis to identify potential issues. Then we move into Phase 2, the review meeting itself. During this meeting, the author, the person who actually wrote the code, walks the team through the document, explaining their logic. A separate person, designated as the chair or moderator, guides the discussion to keep everyone on track. Another team member acts as a scribe, carefully recording every single decision and identified bug. And here is a non-negotiable rule. The meeting should never, ever exceed 2 hours. Analyzing code is intensely exhausting mentally, and after 2 hours, fatigue sets in, and people just start missing things. Finally, in Phase 3, the post-review activities take place. The meeting's over, and the scribe has produced a list of required fixes. Now, the author addresses these issues by fixing the bugs or refactoring the code to meet the agreed standards. But we're not done yet. The review chair must then independently verify and confirm that all repairs were made properly. Only then is the review truly complete. Section 4. Deep dive, program inspections, peer reviews, and empirical proof. Let's zoom in specifically on program inspections, which are a highly structured and specialized form of peer review. A program inspection is where a team from different backgrounds collaborates to find bugs by making a careful, line-by-line review of the program's source code. Unlike a general review that might just look at a high-level design document, an inspection gets right into the weeds of the programming language. They're looking for logical errors, missing initializations, and subtle anomalies that a compiler might completely miss. And get this, because this brilliantly illustrates the power of this method. Famous research conducted by Fagan showed that simple, structured code reading can catch 60% of all bugs in a program. Think about that for a second. Before you write a single automated test, before you even execute the program, you can eliminate more than half of your defects simply by sitting in a room and inspecting the code systematically. But despite this incredible statistic, catching 60% of bugs up front, inspections actually face heavy managerial resistance. Why? Because managers often look at an inspection and just see a room full of highly paid engineers sitting around just reading. They view it as a massive upfront cost and a drain on development time, falsely hoping that standard dynamic testing will catch the bugs cheaper later on in the process. But in software engineering, a bug found later in the lifecycle is exponentially more expensive to fix than one found early. So skipping inspections is really just a false economy. Section 5. Using inspection checklists. How reviewers actually find errors. So if we do manage to get our inspection scheduled, how do reviewers actually find these errors? Well, they don't just blindly read the code. Teams use language-specific checklists to look for characteristic errors, which are grouped into fault classes. We have data faults, which relate to how information is stored, control faults, which deal with the logical flow of the program, input/output faults, and interface faults, which happen when different components try to talk to each other. To expand on these step by step, under data faults, you're actively checking things like, are variables left uninitialized before they're used? Or could this array cause a buffer overflow? Under control faults, you might read the logic of a loop and ask, is there any condition where this loop runs forever and just never terminates? Under interface faults, you're checking if the parameters being passed into a function actually match the types that the function is expecting. By using a checklist, the team doesn't have to rely purely on intuition. They have a solid, structured roadmap for finding common human errors. Section 6, Summary and Next Steps. Consolidating your knowledge for the exam. We've covered a lot of ground today, so let's consolidate this with a quick exam-focused summary. For your tests, make sure you memorize these key facts. First, remember the vital difference in purpose. Quality reviews assess the program, not the programmer, which requires a blame-free culture. Second, know the 3 phases: pre-review preparation, the review meeting itself, kept strictly under 2 hours, and post-review fixing. Third, recall the program inspections are a static, line-by-line peer review. Fourth, remember Fagan's famous statistic: inspections can catch 60% of bugs without ever executing the software. And finally, understand that teams use categorized checklists to systematically hunt down data, control, and interface faults. That perfectly sets up our next topic. We've spent this entire lecture talking about highly structured, formal, and extensively documented review meetings. But the modern software world is increasingly moving toward rapid, iterative, agile methodologies. So I'll leave you with this provocative question. How do we maintain these rigorous quality management standards when moving to fast-paced agile development? Can a strict 2-hour formal review even survive in a world of daily sprints? That's exactly what we'll explore next time. Thanks for joining me for this explainer, and keep studying hard.